Immune-related diseases are expanding during the last decades. Just as an example, mass cytometry studies increased by 155% every year. Today, mainly two techniques are available: flow and mass cytometry, or CyTOF, able to screen more than 40 markers at the same time, generating big datasets that we need to properly study. Many free analyzing tools have been published, but are often underused by immunologists, preferring using manual gating strategies. The most unbiased manual approach requires labor-intensive work. Imagine that you are working with 14 different parameters. It means you should manually create 91 two-dimensional plots. With mass cytometry, the numbers of parameters investigated reach often 40 markers, meaning that 790 two-dimensional plots are needed to see every pairwise combinations. But automated methods exist, and they are free to use. In this course, you will learn how to use them with a powerful and customizable tool named R. Mass cytometry analyzers are so important nowadays that it's becoming requirements to get jobs in companies. This course will make you more employable in the field of immunology. R is a highly customizable analyzer software where most of the bioinformaticians publish the last tools they developed. Other user-friendly tools do not embed such up-to-date analyzers, or if they do, it is with a relative delay. This course concerns any researcher, PhD student or investigators working on flow or mass cytometry data. By following this program, you will learn how to analyze your data without paying any third parties, and by delivering a high-quality output. You don't need to be an expert in R. We'll explain to you every step and make it customizable for your own research. It can be done by either using a Mac or Microsoft computer. You don't need to buy any software to follow this course. You only need one computer with R and RStudio installed, both software being free of charge, as well as your own compensated flow data or mass cytometry data, or you can download the example of dataset we'll analyze together. You can also train on your own data by following the same workflow. The R file will be available for you. If you had in the past some difficulties to work with R, no worries. All the steps will be explained and most of the errors you'll encounter will be detailed so you know how to solve them. In less than 2 hours, you'll know how to analyze your cytometry data. Most of our courses are focused on data science. This course is only about flow and mass cytometry data analysis. By focusing only on this purpose, you'll save your time and be more efficient. You'll be able to deliver very customizable results. You'll see how to pre-process your cytometry data so it looks great on any clustering and visualization method. You'll learn how to perform clustering methods like FlowSOM, Phenograph, and DensVM. Dimensionality reduction methods such as PCA, tSNE, UMAP, and Diffusion Map. You'll learn how to draw a pattern from your analyzers and compare all the analyzers together in no time. Now let's have an overview of the chapters and see how the courses look like. We will work on one flow cytometry dataset and one mass cytometry dataset. The data we use were previously gated on single live immune cells. We'll follow this workflow. You'll learn how to remove some non-informative channels, renaming channels, and enhance the separation between the negative and the positive peak. You'll make your flow cytometry data look great and comparable to mass cytometry data. During your research, did you generate flow cytometry data and still performing manual gating strategy? You might miss some relevant clusters. Let the computer do the work for you in a better way. We'll use the most renowned analyzers like FlowSOM, Phenograph, DensVM, or DensityCut. These clustering analyzers are valid for flow and mass cytometry data. During the visualization step, we'll show you how to visualize patterns in your data. We'll show how to perform statistics on flow data which are considering all the clusters you found. You'll be able to perform dimensionality reduction methods like UMAP, tSNE, and PCA. We will emphasize the idea that cells are not in a static phenotype, but more in a continuous path from one cluster to another. Diffusion Map is a great analysis to see relationships between clusters. At the end of this course, you will learn how to investigate lineage between clusters and see how naive cells are shaped into more activated phenotype. You will understand the difference between clustering analysis, dimensionality reduction, and you will learn how to find the most relevant tool for your data.